Hey everyone, Ronak this side. I hope you all are doing well. So let's see the problem of the day. So the problem today says is total Waviness number in range I range. Okay, so basically we are given a range between two numbers and we have to return the total number of waves between the numbers. Okay, so basically let's see a number like 1, 2, 4, 3, 6, 2. Okay, let's consider this number, and the waviness of number is defined as the total count of peak and valley. We have to find the and number of peaks and number of valleys. Okay, and what is peak and valley in this number? So here 6 is a peak because 6 is greater than 3 and 6 is greater than 2. So 6 is considered as a peak. A digit is peak if it is strictly greater than both of its immediate neighbors. So 6 is greater than 3 and 6 is greater than 2. So 6 is considered as peak. Okay. And what was valley? A digit is a valley if it is strictly less than both of its immediate neighbor. Okay. So a digit is a value if it is strictly less than both of its immediate neighbor. Like here we got 3, 3 is less than 4 and 3 is less than 6. So 3 gonna be a value. Okay. And first and last digit of number cannot be peak or value, and first and last digit cannot be peak or value because they are not surrounded by two numbers. They have only one number. Any number with fewer than 3 digits has a waviness 0, or like we have any number 46, it can only go up, or 64, it can only go down. We haven't got any peak, valley or any peak. Okay, so a number less than 3 digits cannot have peak or valley. So if here we count, after ignoring the first and last, we're gonna count to get the peak. The current number should, if we have this current number that is greater than right neighbor and also greater than left neighbor, and to get the if current number was peak, valley, it should less than strictly less than the right neighbor and strictly less than the left neighbor. Okay, so how to check is 2 is greater than but it's not less than, so it cannot be peak or valley. I mean 4 is greater than 2 and 3. 4 is greater than 2 and 3, so 4 is a peak, and 3 is less than 4 and 6, so 3 is a valley, and 6 is greater than 3 and 2, so 6 is a peak, and 2 can't be anything. So how many peak here we got? We got 2 peak, 4 and 6 were peak. We got 4 and 6 as a peak. We got 3 as a valley. Okay, so how we are going to count? I mean, we have to return the number of waviness, and number of waviness equal to number of peak plus number of valley. Okay, number of peak plus total number of valley. Okay, that's the number of waviness. So how we gonna count peak and valley? A number is, so consider this number contains many digits. So what we are going to do is, first of all, it should greater than, I mean, it should greater than 99. So what we are going to do, we are first taking the, we are going to iterate here from left, because in integers or any digits, it's easier to take remainder or divide it by 10 and keep removing the items. So we are gonna iterate from right to left. So it should digit must greater than 99. Okay, so it's must contain the digit to have, peak or valley. So first of all, we're gonna take out the right index. So we are going to start current from here and end current from here. Current can't become the leftmost or rightmost index. Okay, so this is gonna become right for first. So right equal to digits modulo 10, and the current equal to digits by 10 modulo 10, and left equal to digits divided by 10, divided by 100 modulo 10. And after this, so what we're gonna do, we're gonna remove one element from digits. So we're gonna do digits equal to digits by 10, and we have to check if it's value or peak. So if it's value, then current and less than left, and if it's peak, current should greater than left and right. We got something like value or peak. We can only gonna get one at a time. So if we got peak or valley, our digit can't be peak or valley as Waviness plus plus. Okay, so that's the code, and let's see example by dry running this code. Uh, let's take this digit. So gonna 1, 2, 4, 1, 6, 2, 3, and 1. Okay, so we're gonna count the number of waviness here. Count the number of waviness here, and we're gonna track right, current, left. Okay, so first of all, this is greater than 99. Okay, this is greater than 99. So right gonna be digits modulo 10. So right gonna become 1. Current gonna become digits divided by 10. That gonna delete 1, and modulo 10 gonna get 3. So current gonna become 3, and left digits divide 100. I mean that gonna delete 2, and modulo gonna extract 2. Okay, modulo gonna extract 2. So that's become, and digits equal to digits divided by 10. So we have to just remove the last item, and we have to check is it value. I mean current is greater than right and left, so it's gonna peak. So if it's peak, we do waviness equal to 1, waviness equal to 1, and then again move to loop. So now this time right equal to 3, current equal to 2, left equal to 6. So 2 is less than 3 and 6. So it's gonna become value. So value gonna become, I mean 2 gonna become value. So we increase the count of waviness and remove the last. Then current, I mean right gonna become 2, current gonna become 6, left gonna become 1, and remove the last element as 6 is greater than both left and right, so it's gonna become peak. So increase, so if peak, increase waviness by 1, so increasing the number of waviness. Now right gonna become 6, current gonna become 1, and left gonna become 4. So 1 is less than both 6 and 4, so it's gonna become value. So increase the number of waviness by 1 again. And now after removing, we gonna right gonna become 1, current gonna become 4, and left gonna become 2. So it's, and remove the last item. It's greater than both, for current is greater than right and left, so it's gonna become peak. So increase the number of peak. Now current gonna become, I mean right gonna become 4, current gonna become 2, and left gonna become 1. And I mean 2 is less than, greater than left, but less than 4, so it doesn't count as a wave in neither peak or nor valley. So we just simply gonna remove that and skip that if statement. And now it's not greater than 99, so we're gonna extract the, I mean we're gonna exit the while loop, and the number of waviness we got is 3, 4, 5. Okay, so waviness equal to 5. And if you see, we have 1, 2, 4, 1, 6, 2, 3, 1. So we got increasing from 1, again increasing from 2, again increase till 4, then decrease till 1, then increase till 6, then decrease in 2, then increase till 3, then decrease in 1. So we got 1, 2, 3, 4, 5 points. I mean 5 total number of waviness, 5, where 2 were peak, I mean 3 were peak, and other rest of 2 were valleys. Okay, so this is how we got. And if you notice, we are given a range nums1 and nums2. Like nums1 is 201, nums2 is 205. So we have to sum the total waviness of all numbers. Basically, we got 202, 203, 204. So we have to count the number of waviness here, number of waviness here, number of waviness here, here, and also here. And we got to sum that all. Okay. So we're gonna count one by one, and we wanna write this while loop on a separate function and call that function on every, I mean every input on this range. Okay, so let's write the function first. Waviness, it's gonna take a digit number of wave equal to 0 while digit is greater than, let's just consider it num, while that number is greater than 99, we gonna get the, right, by simply doing num modulo 10, and we're gonna get current by simply doing num by 10 modulo 10, and gonna get the left one by simply doing num by 100 modulo 10. Okay, so after doing this, we gonna, I mean, count, check if it's peak or not. So we gonna check peak. So for peak, the current should greater than left, and current should greater than right too. For, valley, current should greater than right. Current should less than left and right both. And what we're gonna do is check if we got any peak or valley, and we're gonna do number of wave plus plus, and we simply have to reduce, pop out the last element. So we just gonna do the nums divide equal to 10. Okay, so to get the total number of wave here, let's initialize it to 0 of integer type, and we gonna do, and for int I equal to nums1, num1, I less than equal to num2, and I plus plus. We gonna call that Waviness function. Total wave equal to total wave plus waviness of that digit, waviness of that number, and at last we simply gonna return the total number of wave we got. So let's run the code and see if we got any error or not. Okay, we forgot to return the number of waves we got from each digit, and we also forgot to write the return statement here too. Okay, so now code got submitted. Let's submit. We got 3 test cases passed. So now let's submit the code and see. Okay, we got a most optimal solution here. And if you see the time complexity and space complexity of this code, so I think the space complexity gonna become big of once, because we are not using any data structure here, simply using integers, and the time complexity gonna become, if we are given number n to range m. Okay, so the time complexity gonna become the number of digits it's contain, like 2. Suppose it's gonna contain 201, 202, 203, 204, and then 2067. So the time complexity is gonna become total number of digits. So time complexity gonna become big O of number of digits, and space complexity gonna become big of 1. We are not using any extra space here. So that's it for today. I hope you like this video. So please make sure to subscribe to Tensor, and feel free to ask any doubt in comments. Till then, keep smiling, keep coding.